Okay guys, so hopefully you have your notes set up based on the pictures that I provided for you. So remember the two key words that we are going to go back to over and over again when we talk about designing or evaluating someone else's designed experiment are going to be valid and reliable. If they are not valid and reliable, then we do not call them a scientific test and we would not use them to count on the results. So make sure that you have your definition for valid, logical, right? It follows a logical path. It's not just a random idea. And reliable, meaning that it can be done over and over again. It can be repeated. And you're going to get basically the same outcome every time. That way you can be sure of your results. And we need to make sure that it can be repeated by other people. This is a step in the scientific process called peer review, where other scientists or other people studying your topic would need to be able to follow your procedure and come up with the same results as well. If you're the only one who can get those results, then it is probably not a valid and reliable experiment. So we have the steps of the scientific method, which you guys have probably talked about since elementary school. And remember, you don't always just do these one time. You might develop a hypothesis and then realize, oh my goodness, my experiment doesn't actually work, to test that and have to go back and rethink your ideas or make your observations and realize that your experiment maybe wasn't cluing in on exactly what you needed. So this isn't kind of a one-shot deal. These are things you might have to do over and over. But some general guidelines you need to get down when you're designing your experiment. For your question, you need to make sure it is a testable question. It has to be a question where you can test the answer and gather facts and data to support it, not just opinions. Okay, so a testable question. The hypothesis we talked about a little bit when we did the Kahoot game is that your hypothesis is your prediction to the outcome. That is what you believe the answer to the question is. And you base that in logic, right? So you base your prediction to the question, to the answer, with logical reasons, facts that you know, background information. You might even do research before you form your hypothesis. Then, once you have a testable question and you believe that you kind of know the outcome or you have a guess about what you think it will be, you can design an organized investigation. And the point of your experiment is that it is to prove or disprove your hypothesis. It is not just a fun, cool activity that you want to do. It is a test of your hypothesis. So your experiment must be on topic. Observations are made during the experiment. These are the results that can be seen or measured. We know that's our dependent variable. If I have a test without any results I can measure, then I don't have a dependent variable and I don't have a valid test. So I must have results that can be seen and measured. Once I've completed my observations and experiment, I really need to go back then and look at that data. I need to analyze it. I'm looking for trends or patterns, something I can use to draw logical conclusions about that test and about my hypothesis. And then your conclusion, your final conclusion, is simply your organized report of those results. So I have analyzed it, and now I'm going to put that into writing, and I'm going to be very step by step so that, remember, when it's under peer review, I have very organized information for people to go back and consider. So your conclusion is the outcome of the test. Your conclusion should say whether your hypothesis was correct or incorrect. Why? How do you know that your hypothesis was correct? What was the information that allowed you to draw that conclusion? Or if your hypothesis was incorrect, which is no big deal, that's why we do the test. Why was it incorrect? What happened that was unexpected for you that made you think the other answer would be correct? And then this is always something that scientists do. They ask more questions to look further into the topic. Is there another experiment that you might do to learn even more? So you always look for those extended questions on your test. Okay? Now when you begin to design your experiment, you're going to follow those steps. Okay? And so we just have some basic rules to kind of go by for scientists, because in order to be valid and in order to be reliable, scientists need to work off of the same rules. So this is kind of a summary of those steps. Rule 1, your experiment must test your hypothesis to show if it is supported or not supported, right? Should have said supported. Again, it must be on topic. You don't design an experiment just because it's cool and fun. It needs to test the hypothesis. Rule 2 is that your test should be measurable and objective. Remember, if you have nothing to measure, then you don't have a dependent variable. And objective, we'll talk about what that means. We saw it in our Kahoot game. So measurable, you use the universal measurement. Make sure that you're using the metric system. That way when it goes to peer review, everyone is speaking the same language as far as measurement goes. And objective means there should be no opinion or bias in your test. So we saw an example in Kahoot about the boy that wanted to see if he was the best rapper or singer or something like that. But he had bias because he had a personal opinion about his abilities. So there should be no bias. That's what it means to be objective. Rule 3 is that the test should be repeatable by other people. Other people should be able to see an organized and detailed set of procedures. So you really have to go step by step in order to write those details down. Don't assume that people know. This will allow peer review and repetition, right? So you have to be organized in your procedures. Use standard tools. Don't use some kind of contraption that you made at home that nobody else would have access to, because then they can't do peer review. So standard tools and the metric system, standard measurement. And then, of course, there should be a clearly written conclusion or report that others can refer to get a better idea about your test and the outcome and what they should be watching for. Okay? So when scientists are doing experiments, they are usually trying to prove, they're always trying to prove or disprove something. And so in science, you're going to hear two different terms used a lot for scientists' findings. You're going to hear the word theory, and you're going to hear the word law. Okay, so there is a big difference between these. And as you get older and you begin listening to people that are making a case for something, you need to know the difference between a theory and a law. So a theory is an opinion or idea, but it has enough evidence to be generally accepted, meaning it is an opinion or an idea, but there's enough proof that most people believe that that it is true. Okay? The key to that is that a theory has not been proven conclusively as a fact, They think it's probably true, it has a lot of solid evidence, but we do not know that it is a fact. So there's always the possibility that the theory could still be disproven, even though it has a lot of evidence. The difference in that and a law, and you probably remember from earlier years, like in Newton's laws of gravity and force and motion, a law is laws are universal facts. They have been proven conclusively. We know for sure that they are true. They can be seen and observed and measured and proven time after time after time. And so we're not relying on an idea that has support, but conclusive evidence to make it a fact. Okay? So it's important you know the difference in those. Now, if you had trouble keeping up, obviously I hope you figured out that you could just pause the video in order to kind of catch up on what you needed to write. Okay? So you can go back, rewatch, pause, and get each step along the way. And make sure you have your notes ready for class on Wednesday.